All right. So has anyone ever heard of regular expressions before?
Yes.
Yes.
Couple people. Have you used them?
I have. You
Yes.
can use them to match, or so you can include or exclude patterns within a string.
Okay, patterns within a string. You so let's say I have, let me share my screen. There's a webcomic, just a sec, but oh no, the killer must have followed. No, it's like a fantasy. But to find them, we'd have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. Okay. So yeah, maybe we'll talk about it, and then we can the comment may make a little more sense. So let's say I have a bunch of text. So if I want to search for stuff, like I know how to search for stuff, right? So I do Control F, and I want to look for language, and I see, oh, I got a hit. So is there a problem with that, or?
Well, it's better if it's looking for like patterns. Like if you had an IP address you were looking for, you could look for something specifically that had 3 digits and a dot, and 3 digits and a dot, 3 digits and a dot, etc.
Okay.
So instead of for actual string, you're looking for patterns within a string.
Okay, good. So it's so I could look for exact. So if I were looking for an IP address, so I don't know, 123 dot whatever, something like that. So if I knew exactly, if I had a list of IPs that I was looking for, I could do a search for those specifically. But if I wanted to search for any IPs, if I had, let's say, log files, with 1 million different entries, and I wanted to get all of the IP addresses, then you wouldn't know ahead of time what you were looking for exactly. So regular expressions kind of solve the problem of making searching through text a little bit more extensible, or it abstracts away from, like, I want to search for this specific sequence of characters to I want to search for some pattern, and that we keep saying pattern and may not make a whole lot of sense until we actually see some examples. So can anyone give an example of an application of using regex that they've actually done?
You can strip. Oh, sorry. Go ahead.
Oh, you're good. Go ahead.
Yeah, you could strip, but like if you are using an API and the data is kind of dirty and it's got some like malformed characters like HTML in it that got inserted there somehow, you could strip all that out with certain regex.
Okay, right. So you could look for HTML tags.
Right.
Without having, so you could, so without regular expressions, you could, so if I had some HTML tags in here, so if I wanted to, for example, I only cared about the stuff that was inside of HTML tags. You could potentially, if you had a list of every possible HTML tag that might show up, you could search for those, but that gets very complicated. So yeah, again, that's a good application where you have something that looks like an open bracket and then some character. Maybe you don't, character or characters, you don't know if it's one or many, and maybe it doesn't matter, and then a closing bracket. So you could describe an HTML tag. So let's go ahead and actually let's just look at that real quick. So if you were going to describe an HTML tag as a general pattern, how might you do that?
It's gonna if it's something you're trying to strip out, it's probably not a complete tag. It's probably malformed. So
Okay.
it's probably going to have an opening bracket and maybe not a closing bracket, something of that nature. So you got to account for numerous different scenarios.
Okay. But let's just assume, for example, for the sake of simplicity, that we have correctly formed HTML tags.
Opening bracket, closing bracket, and a predictable number of tags. There's not an infinite number of HTML tags. It's going to be a P or an H1 or an H2.
Yeah, I mean there are, but you can't actually make your own HTML tags. You can
that's new info.
It would, like a less than, some text, and then a greater than would be
right.
what I would be searching for.
Yeah, and then maybe if we wanted to keep going, and then we have some text, some stuff, some undefined stuff in the middle that we care about, and then we have another one with a backslash and then something. So this would be very complicated and basically impossible to do with just normal searching. So let's switch over. I'm going to use Regexer. There's a whole bunch of similar kinds of things, but so this is a tool. So we're going to talk a little bit about it, but mostly I'm just going to give some examples because, trying to talk about regular expressions in the abstract is difficult. So I'll start by saying regular expressions is basically its own mini language, like a very purpose-built language that's used for searching for patterns in text. And it can get very complicated, and it's kind of very esoteric looking, especially at first, but you don't have to become an expert. So don't feel like you have to become a regex expert. So this is an online tool that I'm using. It's just convenient if you want to play around with stuff and test things out. So when I come here, there's some default text here. So here is the regular expression, and everything highlighted in blue is a match. So could someone describe for me what this regular expression is picking up?
It's looking for capital letters A through Z.
Okay.
Slash W plus, what is a slash W plus? I'd have to look it up.
Well, so I'm not expecting anyone to understand the regular expression right now, but if we look, for example, at the hits, could we describe the pattern that?
Oh, it looks to be hitting anything that has a capital letter in it. So any word that has a capital letter is returned.
Okay, so if I did something like so this word doesn't get picked up. So can we be a little bit more specific about?
So does that little W mean that means no special characters?
Yeah, so, but again, I'm not, I don't want to focus on the specifics of this regular expression. I want you to backwards engineer what this regular expression means and what it's doing, since you have a lot of examples of what it's hitting.
Okay, because I'm going to slightly put my mouse over top what's happening, but the range is A through Z capital, and then it's matching a word. That slash W is the word, and then there's a quantifier, so it's going to match one or more of the preceding tokens. And then the slash G is a global search.
Right. So that's all true, but that's not backwards engineering. So if we see these examples, right? So we have it's hitting on. Okay, so it looks like every word starts with a capital letter, right? So every word starts with a capital letter, and then there are some undefined number of, looks like a combination of lowercase and potentially uppercase letters following that, right? So we could try testing out, is there a limit to how many letters or how many characters it will be? Doesn't look like it. I mean, I'm not going to do this forever, but so it looks like it's picking up on words that start with capital letters and have any number of upper or lowercase letters following.
And numbers, because you got the number on the second line there.
Yeah. So here's an example. So this is just me trying out some other things. We can see that this 0 gets picked up and this 7 gets picked up, but the close parentheses doesn't, and the dash doesn't. So, when you're doing stuff with regular expressions, there's going to be a lot of experimenting and playing around with stuff. So it's good to get used to that. So what this is doing, I can explain this. I'm going to get rid of these parentheses because you don't need that right now. So we have brackets, open and close brackets. Then we have a capital A and a capital Z. And this dash in the middle basically means the set of capital letters from A to Z. So all capital letters in the normal English alphabet. And then this /W, the /W is what's called a meta character. So there are meta characters which allow you to, again, these are kind of generic classes. So if I hover over the word, matches any word character, alphanumeric, and underscore. So I'm gonna delete all this, and we're gonna start with some simple stuff. So if we have a word here, and I would like to match apple. Now, if I were doing my initial naive kind of, I open a text file and I do Control F and I search for stuff, I would just do APPLE. And it turns out that you can actually do this with regular expressions. So at the simplest level, a regular expression can include what you just do with Control F. So it starts with this literal character, a capital A, followed by a capital P, and so on. Right? So apple will match and orange does not match. And if I remove one of the P's here, then this no longer matches. So regular expressions can be literal characters. So, this capital A is just the capital A and followed by a P, followed by, and so on. You can also do, you can have there are two other sets of characters. One is quantifiers, which tells you basically how many of the preceding character you're going to have. So if for whatever reason, let's say APPLE, so you could write P twice. You could also specify it here. So I'm saying I want a capital A, a lowercase p, and I want two of them. So this is how you indicate that here. So I'm gonna just so you know, don't feel like you have to memorize all this stuff. This is just exposure, and then you'll look up stuff as you need it. So what I'm saying is AP and then open and close curly braces and then 2, and this is exactly 2 of the preceding character, which in this case is P. So I want A, 2 P's, an L, and an E. So if I have 3 P's, then this is no longer going to match. So this is an exact match. So you can do that. You can also, you can have other kinds of quantifiers. So you can have APPLE, this matches now. If I do a question mark, then this means 0 or 1 of the preceding character. So this would match with APLE with 1P or with APPLE. So again, this is literal A, literal P, and then 0 or 1P followed by an L and an E. You can also do things like plus. So a plus could be 1 or more. So in this case, I can do this. So AP plus means an A followed by at least 1 P followed by an L. So I can add then P's forever here, and that will match. You can also, in addition to the plus, there's also an asterisk. And an asterisk means 0 or more. So I could have lots of P's again, and I could have no P's. Okay. So that's for Apple. So I'm going to introduce some other things right now. So the most general regular expression that will match everything is dot asterisk. And the dot is another meta character. So a dot is a meta character, and a dot means any character except line breaks. So a dot is any character except line breaks, and an asterisk means 0 or more of any character, basically. So this will match, you know, basically everything. But what if I had what if I want to match the last word of a sentence, for example? Or let's keep it to here. So I want to match this word.
I guess you would look for the period and a word preceding it.
Okay, so THERE. So that matches that. And then a period.
But you'd want, instead of using there, you'd want to match any word. So you would
Right. So let's start with this like very concrete
Okay.
example, and then we'll make it abstract. So I want to focus
Okay.
on the period first. So we have hello there. So does this work? Am I matching their period?
yes,
You need-
highlighted.
Okay, it's highlighted. What if I did? So that also matches.
Do you need to escape the period so it's not?
Yeah. So this
Yeah.
this happens with regular expressions a lot. Something you have to be aware of, because there are meta characters and then literal characters, and a period happens to be a meta character, but you can also actually just have a period. So a period as a meta character, as a character class, means any character except for line breaks. So if you want to use it for a literal period, you have to escape it. So when you escape it, but the slash, you're saying, you're no longer a meta character, you're just a literal period. And so now question mark doesn't match, but period does match. Okay, so let's Okay, so now let's try to write a regular expression that will just match the last word, including a period. So how would we, let's just think outside of regular expressions, how would we talk about this problem? How would you describe what you're trying to match?
Combination of alphanumeric characters followed by a period.
Yeah, I think that's a good description. So some number of alphanumeric characters. We could be more restrictive and say just alphabet characters, but alphanumeric. So it kind of depends on what exactly our problem is and what our data set is and so on. But yeah, so we don't know how many, but we know that, I mean, could there be, for example, something like this? Could you have by space period? I mean, would that be possible? So again, I don't want to get into all this, but especially when you're dealing with regular expressions, you often realize how many edge cases you actually have. So here we have, so how could we write a regular expression that would be some number, let's say at least one, so at least one or more letters?
Period.
Uh,
So we could do this. You can always do that. That's always an option. But we don't want to do that.
I think we go back to the escape W that we had for any alphanumeric character or the underscore, and then followed by the asterisk would be any number of them, and then followed by the escaped period.
Okay. So this will work. This is, any alphanumeric. So we'll, and then this asterisk means 0 or more. So that would also match. What if we didn't want this last one to match?
You'd leave out the space. You'd have to say escape capital S gets rid of the space. So in front of, after the word, after the escape W asterisk,
Okay.
escape capital.
Yeah. Okay. So we could try doing something like that. So this is the opposite. So there, yeah, we'll talk about that in a sec, but these character classes can also be negated, and usually it's the capital. But is there a way that, so we have a quantifier here, which is saying 0 or more. But we don't want there to be 0. So
Change it to plus.
yeah, so we could change the quantifier. So now this last one doesn't match. So we have to have at least one letter followed by a period. What if we only wanted 4-letter words followed by a period?
You could 4-letter, say that again, 4-letter words
Yeah.
followed by a period.
Yeah, so I'm gonna hit fine and not the other two.
/W with the curly brackets.
Okay,
And 4, I think.
okay,
I was just gonna grab 4, so it has to.
yeah. So this is good. I'm not gonna worry about this. There are, yeah, so we'll just ignore this, but yeah, so we got this one. So that works. Okay. Okay, so I'm gonna go back to hitting all of them. So this plus sign. All right. So we have this word class, but maybe this is not, this is maybe a little bit magic or something. We could also be more specific. So we could actually say what characters we want to accept. So if I only wanted to get fine, I'm fine, I could do F-I-N-E. And this works here. But again, it's a bit strange here, but inside the brackets, this is not like the word fine. So I could do I-N-E-F and it would still match. So when you have characters inside of brackets, they're still literal characters, but it's like you have an or after every single one. So I want one or more of an I, an N, an E, or an F. So if you have any of those, then that will count. And you can also do like ranges, as we saw earlier. So A to Z, this is all the lowercase letters from A to Z. So A to Z, capital A to Z, and then I think underscore is the same thing as /W. All right, let's see. Are there I think that's the basics for, I think that'll be good for now. Are there any questions about that so far?
I noticed that this all says it's in JavaScript. Is this also the same for Python, or is this only usable with JavaScript?
Yeah, so regular expression, it's actually its own thing, and I'm not entirely clear on the actual origin. I think it started in Perl, if I'm that maybe not. So there's another programming language called Perl, but it's basically its own separate kind of mini language, and it gets used. So every computer programming language will have regular expressions, and there are some minor differences, but they're all basically the same. So yeah, JavaScript, Python, it's all going to be the same. I would, for all intents and purposes, it's the same in every language. Okay, so speaking of Python, let's try to use regular expressions in Python. All right, so yeah, we'll start here. So I have this file, which is actually, it comes from here. I can, yeah. So this is, has anyone ever heard of this? Like PEPs? So Python is, it's a language. It's developed by lots of people. It's like a group effort. So here's the Guido van Rossum. He's the, I guess the inventor of Python, but it's kind of like run by committee. And so if people who want to change things have to write proposals, and they have these, they have a whole bunch of these PEP documents, which are proposals. So here's one for the with statement, which we saw a little bit on Saturday. So it's a it creates a context, and it's used commonly for things like opening files. So what we're going to do is we are going to write a short Python program, a script that will read from this file, and then we'll do some regular expression stuff on it. So I'm going to create a file. All right, So I have this this open right now, and I want to open this file and read the contents in. So you could just open it directly. There's actually, you can just call open. But the issue with opening files is that you want to make sure you close them when you're done. So every time you open a file, you want to make sure you close it. And if you open a file and there's an error or something, the program will exit and you'll still have an open file hanging around. So you don't want that. So the with statement basically is an API, or it's a way of writing code that's available in Python. And if you use the with statement and you call something in there, then it will basically do some kind of initial action and then a closing action. So it's similar to when you're writing a test, like test in Python, and you have that setup method. So setup, do something first, and then I'm gonna run my tests. And just to show you, you know, kind of another example of that, let me do. I'm going to show you what happens kind of under the hood when you create an object, or you know, an instance of an object. So we all know about init, and what's the deal with init? Let's see what we got. Ka, what is init?
Can you hear me? Init is the method to initialize the class.
Yeah. Okay, good. So I'm going to create an instance here, and I'm going to run this program. And so I created, init gets printed here, which means that this print statement ran, which means that this method got executed. So all I did was create an instance of this class, but Python under the hood called this method. But that's not the only method that it calls. Turns out there are a couple more. So def don't worry about this right now. Talk about it later. So if I now create an instance of this class, we'll see that this other method also got called. And not only did it get called, but it got called first. So it turns out when you create an instance, there's this you know, Python internal method that Python will call automatically. And once it calls that, this actually creates the instance, and then init gets called after to basically populate it with those initial values. And in addition to those two, there's also, so it's not just, you know, so there are things that happen at the very beginning. So this is when it gets created, and also when it gets destroyed or deleted. So notice that I'm not like, you know, I'm overriding these methods so that I can throw out a print statement here. But Python is calling all of these, even if I didn't have them, Python would be calling them. I've just kind of made them visible here. So delete will happen basically once you're no longer using it. So if it's going to get garbage collected, excuse me, So if I were to kind of pause this, so. Okay, so I'm going to create an instance and then I'm just going to pause the program for a couple seconds and we'll see what happens. So new and init get called immediately. And then it sleeps and then delete gets called. So delete won't get called until the end, or basically till there's no more references to this instance. Okay, so you don't necessarily need to know all this, but there is under the hood, there are all these like life cycle things happening. So Python is doing more than it looks like, and the with operator is similar. So it will do something at the beginning and do something at the end. So with, and I'm going to open this file. So you pass in a string, and the second parameter is basically the mode. So do you want to read or write or whatever? R will be for read. And then I can, so it's basically going to create an object for me. In this case, it'll be a file object, which I can rename here. So I can use as file, you can call this whatever I want. I'll call it file object. So I'm going to open this in a particular context, and we'll take a look at that in a sec, as file object. Now what I'm going to do is print, well, first we'll print the file object. So this object is a io.text IO wrapper. So you don't need to know what that is, but this is a file object. And does anyone know remember what dir does?
Lists all the methods.
Yeah.
Go ahead, Stephanie.
Yeah, that's right. So it'll basically tell you everything that this instance has available to it. And let me minimize that. So we can see all the stuff. So there's a whole bunch of dunder methods. So del, which we just saw, is there. Dir, which actually we just called. So calling dir as a function is the same thing as this. We could actually call file object dunder dir if we wanted to. Enter. So enter and exit are what the with keyword uses. So if you call this with, it's going to call enter. And in this case, enter is basically just going to open the file. And then once you leave, including if there's an exception, so it'll handle exceptions, it will call exit, which will basically just close the file. So we could do all that ourselves. We could open files, check for exceptions and then close the file, or we can use the with operator and basically we don't have to worry about it anymore. Okay, so that's basically what the with operator. So almost all this stuff is just controlled. So you can write your own. Context managers that will work with statements. So you could write a class, and as long as you have an enter and exit dunder defined that do what they're supposed to do, then you can write your own custom classes that will behave with this built-in Python keyword. Okay, so we have this file object. So I'm opening the file now. I'm going to open the file, and I can read. So there's a whole bunch of methods, as you might expect, including read. So there's, let's see, what do we got? buffer, close, attach, opening, seek, tell, truncate, writable, write, and so on. So there's a whole bunch of stuff that you can do. Let's just read that for now. Let me change this to contents. Okay, so now I'm printing out everything that was in that file. So I opened the file, I read it, I read in everything, and now I'm just printing it out. So it's just one big blob now. You don't have to read it as one big blob. You could do read lines. There's a couple other, this is stuff that you could just, look up and, but now we have a list. So every line will have, that has its own item here. So we can also loop over that, right? So you do for content. Let's just do. And it'll just print them out, adding a new line basically. Okay, so that's pretty much it for opening files. We'll talk more about this later, but this is just an initial exposure. So we can now open a file and we can take a look at the contents. All right, so let's start doing stuff with regular expressions now. So first thing to know is that in Python, the regular expression module is part of the standard library. So it's not core Python, it's standard library. So you have to import it. And it's called RE. So we don't have to download it. It's not a third-party thing, but we do have to import it. So we import RE. And then RE so you can actually look at Python code if you want, the option, and then click depending on what it is. So, some Python stuff is written in C actually, but so here's the whole module. It's less than 400 lines. So this is, if you want to take a look, you can see what real professional code looks like. This is also kind of old, so you also see that there are examples of things where you can't change it because it will break other stuff basically. So that also happens a lot with software. So there's a bunch of comments, and then there's a description, right? So like half of this is basically notes and descriptions. There's some imports here. And then, so this is in enum. So this is basically like storing some constants to use here. You don't need to worry about understanding all this stuff. So does anyone remember what repr does? Thunder repr?
It's like if you go to print an instance of the class, it'll pretty much print out whatever you put in that method.
Yeah, it's basically the same thing as Thunder str. It'll give you a string representation, but repr is usually supposed to be like what like the class would actually look like. So basically you should be able to execute whatever the string representation is. So not just like, this is my class and it's so great, but like class name, parentheses, whatever parameters you have, kind of stuff. Okay, and then here we have the public interface. So this is the API. So modules, when you when you make them, you'll have internal stuff that's, you know, the users of your module don't need to worry about and shouldn't worry about. And then you have the public interface or the API, which is what you have exposed, basically what people will use. And we have all these methods that are available, like match, full match, search. And you can see, if you look here, I mean, so can someone tell me anything they notice about these functions? Is someone, I hear a faint whisper somewhere.
I'm not sure if this is what you're looking for, but it reminds me of the unit test module and the methods it was using to compare, just how it's kind of laid out and how you can use it in your code.
Okay, yeah. So it reminds you of the unit test library. Yeah, so there's a method, and then there's a doc string here, which I don't think we've done, but it's always a good idea with your unit tests. But I mean, one thing that I noticed is that all of these, so they have different names, right? Match, full match, search, whatever, but they're all, at the end of the day, calling this same method, this underscore compile function. So what does the underscore mean? I don't think we've really talked about this, but an underscore basically means it's a private method, which means that you using the public interface shouldn't be using this. So it's, in some languages, this is enforced. In Python, it's not enforced. This is just kind of you're telling other developers, you're saying, hey, this is just for internal use only here, this compile method. So if you want to use this from the outside, you call match or full match or search. But on the inside, things that are on the inside can call this compile thing. So let's see if we can find compile. So here we have this compile, and we don't have to look at what it does, but so someone was asking about memoization. So this is a decorator that handles memoization. So it's going to cache calls to the function. You need to worry about any of this, and if this looks like just nonsense, that's fine. I'm just showing it to you to show, one, that this is real, like the people who do this are like the best coders. So that's this is what real code looks like. Okay, so I'm going to import that, and all this means is now I can use all that code that we were just looking at. That means I can use it now. So import RE. So for line and contents, so there's a whole bunch of methods on there. Let's look at the documentation real quick. So there's sometimes the Python docs have like two sets of documentation. There's like the real documentation, then there's like a how-to or something a little bit more conceptual or practical. So we'll look at that real quick. So I would take a look at this. I'd encourage you to take a look at this. But it just talks a little bit about what regular expressions are and then how to use them in Python. So we see this, like, there are these character classes /d we didn't look at, but that's the numbers or the digits. And then we have here like one thing and the opposite. So lowercase d is 0 through 9, uppercase d is anything that isn't 0 through 9. Let me do. So there's some methods we can call that we actually saw there. So the main one will focus on search. We'll also look at find iter, but so search will scan through a string looking for any location where a given regular expression matches. So here's pattern dot search string pause. So can anyone tell me, does this look like nonsense?
So it's gonna search a string, and then I guess that's the position starting and the ending position, maybe?
Yeah.
Could have read
Yes.
down below it.
Yeah. Exactly. So what are these brackets for? We don't call functions with brackets, right?
Doesn't mean they're optional parameters.
Yeah. So this is kind of a standard convention. So you'll see this in documentation where if there's something in brackets, that means it's optional. So this pattern dot search is actually just a function, but ignoring that for now. So you can pass it, all it requires is a string. You can optionally pass it a string and a position, or a string and a position and a starting position and an end position. Let's see. So we scroll back up here. So here's an example. So we have a pattern, and then we'll search for a pattern. We'll actually do this a little bit differently. There's another way of interacting with it, but if you get a hit, it'll return you a match object. So that we'll get a match object, and we'll have to do something with the match object. And if you don't get a hit, if your regular expression comes up empty, then you'll just get none. So I'm going to do this search, and you can pass in a regular expression and then the string that you want. So there's two ways. It's a little confusing from the documentation, but there are two ways of calling this. You can actually like create a compiled regular expression and then call search as a method, or you can just call search independently. So we're going to call search independently, and we're going to pass in a regular expression. So we could look for anything really. Let's just look for capital, words that start with a capital letter initially. So you can do that. We can define this outside. So we'll just do that for the sake of clarity. So our pattern will be, and then this is not strictly necessary, but there's this R, which means, I believe means raw string. So when you are doing regular expressions, this just says literally use exactly everything that I typed. So it eliminates the need to escape certain characters. All right, so if we want to write a regular expression pattern that will look for a word that starts with a capital letter.
Wouldn't it brackets A through Z?
Okay, we can do that. A through Z. Okay, so that'll get us a capital letter. So, however, I have however.
What did you want? Oh, okay. I'm sorry. Did you want a whole word or
Yeah,
just?
Yeah. I want words that start with a capital letter.
So the escape W and asterisk that would grab.
Okay, so you could use a character class, and then any number of. So let's give that a try. So we're going to call search, and we're going to pass in the pattern, and then we're going to pass in the string that we want. Let's see. We'll call this match return. So we're reading from the file. We're gonna basically create a list of all the sentences. And then we're going to search in every sentence for this pattern, which is a word that starts with a capital letter, followed by some other stuff. And this match return, if there's nothing, then we'll get none. And if there's something, we'll get a match object. So we should check if it's none, basically. So if match return, or we could do if match return is not none or anything else, but this will work. None is falsy. So if match return, then I'm just going to print this out for now. Okay, so let's run this. And we get a whole bunch of match objects, which maybe are not all that helpful to look at, but so we have a regular expression, we search for it, we got a hit, so we get a match object. And then if we want to do something with that, we can, if we want to just look at the actual word, there are a whole bunch of methods and stuff you can look at, but group, we'll do group, and that will give us the actual words. So, so that's basically it. So the regular expressions are the same. You just have to package them up and include it with Python. So we'll do a couple more examples. So let's, since this is about programming, let's take a look at these dunder. So let's see if we can find all of the dunder methods here.
Hey, Chad, I have a quick question if you don't
Yeah,
mind.
sure.
That match return object, when it had that attribute value combination on the end of it with match, can you find just the property match of the match return object?
I'm not sure. It's a little confusing. That may not actually exist. You would think that would exist. Yeah. Because it says,
okay.
Yeah. So I think that's just kind of unfortunate design, but there are definitely some things about the regular expression module that are a little wonky in my humble opinion, but.
Got it.
I've got a question too. Is there a way to like loop through that group response to like pull out each value?
So this is actually only, so that's another thing to keep in mind is I think this is actually only going to get the first hit. So there will only be one per line. So whatever this text is, so there are other flags that you can pass in. And I think the documentation talks about that. Capital I believe that's not going to help me. Yeah. So there are flags that you can pass in. Let me see if this will help. So you can pass in these flags, which are constants, which basically will give you things like ignore case, right? So you can write a regular expression, and then you can say just ignore the case, or multi-line. So this is used when you have this other character, which we didn't talk about, but you know, there's a lot of things we could talk about, but there's a way to check if something is the beginning of a line, and this multi-line will basically give you more hits, and then there should be a global somewhere. That doesn't show up. Well, so there's another method that you can use in any case to do that. So all of these methods are very specific. So I believe search will just return the first value that it gets. There's another one that we can use. So a couple ways to handle that. One is to break up everything into like if you're searching for individual words, then break everything up in individual words. So here we have this array of sentences, basically. We could further split that on like white space or something and get individual words. So we could try individual words, and then we could run a regular expression check on each individual word, and that would get us a list of every single word. So there's a couple ways you could handle that. So I'm gonna do, let's do find eater. Let's see. Well, let's keep going. Let's find some dunders first. For line and objects, let's do for word in line dot split. We'll split on spaces. This might not be the most, trying to tokenize words and text is kind of its own thing. This is, this will work for our purposes right now. And then word. If we do that, we should get more results. Okay, so let's focus on this pattern now. So we want to find all of the dunder methods that are used in this text. So can someone, let's see, I'm gonna pick on someone now. Brian, can you, so if I have a dunder method here, so can you just describe for me in general what this is?
Describe what the dunder is, or describe what the regex would be to find it?
Yeah, the general pattern. So you don't have,
okay.
Give me
so
the
you got
as a pattern.
We're going to need to search for something that begins with 2 underscores. And if we're looking for any dunder method, then if we want to return every dunder method, then that would basically be it. Anything that starts with 2 underscores and has any number of characters afterwards followed by 2 underscores. So
Okay.
I'm not exactly sure on the regex pattern for that, but
Yeah,
that's what we need to return.
I think that would work. And if I were, if I were doing this, if I had, a text and I was trying to figure stuff out, I would do some initial exploration, and that, you try it with something like that. I mean, that's a good opening salvo, and then you look at your results and see if you need to make tweaks. So we'll start with that. So we'll do 2 underscores, and that's just going to be a literal character. I think that'll work. 2 underscores, and then some other letters. Let's say that they have to be lowercase letters.
Bracket with the range A to Z in it, both lowercase.
Okay, A to Z. And how many of those characters do we need?
If we're looking for every instance of the dunder, we don't really know, because some of them are 4 letters, and others are 3 letters, and so we don't really know.
Okay, good. So again, this is kind of a domain specific question, but let's just say that you have to have at least 1 character, and you can have as many characters as you want.
Be an asterisk.
So
Plus sign?
Yeah. So what's the difference between an asterisk and a plus sign?
The asterisk is anywhere from 0 to unlimited, whereas the plus sign, there has to be at least 1.
Yeah.
Moving up.
Yeah. So asterisk is 0 or more, and plus sign is 1 or more. So we want at least 1, and then we can have these 2 literal characters. So let's try that. Oh, let me get rid of that. So we got a whole bunch of these enter, exit, which we already looked at. So enter will get called here initially, and the exit will get called at the end. But the only ones there are, I thought there were more than that. Maybe not. Okay, so okay, so we have these dunder methods. So this will work for dunders. What about like a function? If we just want to. So there's these dunder methods. There's also some other functions that I can see, like close or whatever. So let's not worry about every possible edge case, just, you know. So my func, something like that, with maybe optional parameters. So what kind of regular expression would work for a function?
To be the global W flag with a plus sign and then the open and close parentheses as an exact match.
Okay. So you could do, it's got to start with some kind of characters, at least one, and then open and close parentheses. So these are literal characters. All right, let's see what we get there. Again, that.
I think they need to be escaped, the parentheses.
Thank you. So this is something you'll, so I wanted these to be literal characters, but parentheses are actually significant in Regex. They're used for groups, which we're not going to talk about now, but that's another part of Regex. So it looks like we've got a lot of hits. What if we wanted optional parameters? Or let's just say optionally one parameter.
You need that plus sign.
Okay, so we have, we're going to start with, let's say, any kind of characters, and then an open parentheses, and then maybe or maybe not something here, and then closing parentheses.
Period asterisk.
Okay, so period asterisk. So this could be anything or nothing. So I think, yeah, let's go with this. So we might have more specific use case, but now we can see that we have, we're picking up these functions with parameters. Okay. All right. Let's see. So I'm going to keep this the same. I just want to, I'll show you find iter. So you have you can look at a different method. So it's basically the same thing, but so I'll copy the first line. And then, so I can do, let's see. So find iter will basically give you like a generator, which you can think of as basically a list of results. So I'm going to do this here. So we'll do the same thing. We'll find all the functions, find iter, and here I'm just going to read in the entire file. It's just one giant string. Make sure this works. Okay. And then matches, so we can, let's take a look at what matches is. So it's something called a callable iterator object. I have no idea what that is, so let's see what it is. What can you do, callable iterator object? Well, it can do a few things. The most important to its being an iterator is this next method. So again, when you have stuff like stuff that can be looped over, which isn't iterable, so a list isn't iterable, this thing isn't iterable, just like you can make something behave as a context, a context operator by including certain methods. You do the same thing here. So next is a method on a class, and you could write your own classes that are iterable. You just have to implement this dunder next and then do the expected behavior. So all of the, all of the magic stuff under the hood usually ends up being some kind of dunder that's implicitly being called. So when Python is going through a for loop, it's actually calling like the next dunder on whatever it is. Okay, so we have this matches. So I know that because it has a next dunder that I can loop over it. So for match in matches. Let's see what we get. And we get a whole bunch of match objects. So you can do the same thing. So again, it ends up being the same thing, right? The match object. And so we'll do group. And I think this is actually returning, it's a regular expression, maybe a little too broad. Any number of words, yeah. So let's say, I'm gonna just adjust this a little bit.
Can you use the quantifier after, whether it's A to Z or the white space, can you use the bracket notation and say just 3 or 4 characters followed by parentheses?
Yeah, you could definitely do that. So you could have instead of here, we could have, let's say, a lower limit, we could say 1, and then an upper limit. We could decide on whatever we want, 10 or whatever. But this is an issue you'll run into where you'll have to, yeah, that's still picking up everything. I have to play around with this. I'm not sure why. All of this trends. So this is getting cut off. So it's picking up this, but then it's getting everything else as well. Because it's probably this would be my guess. So it sees this closing parentheses here and this opening parentheses, and it's grabbing everything, grabbing everything in between there. So that's kind of the name of the game with regular expressions. It's a lot of mystery and guesswork. But yeah, so I'll leave it at that for now. So again, regex, you don't need to learn it. You don't need to become a regex master, but you should be able to do some basic stuff, and you should know what it is and be able to look up things. And I'll stop here and let's take a look